All right. Good evening, guys. This is day two of week 8. Today we are going to be going over remote state. Uh, for the past 2 weeks, you guys have been working with your Terraform state being in your local system. Uh, Today we'll be talking about how you can use S3 and DynamoDB to create that state lock, as well as keep your state file in the S3 bucket so that if you're collaborating with other teammates, you guys aren't going to run into any problems, and you guys can all edit your infrastructure. So let's get started with today's plan of the day. So remote state, day two, team collaboration and state management. Remote state transforms Terraform from a solo tool into a team collaboration platform by centralizing state storage and preventing conflicts. Using S3 and DynamoDB as a shared backend enables professional infrastructure as code workflows where multiple engineers can safely manage the same infrastructure. This approach mirrors how enterprise teams coordinate infrastructure changes across complex cloud environments. What are we trying to accomplish? We'll implement remote state management using the S3 and DynamoDB services you learned yesterday. You'll migrate existing projects from local to remote state, configure shared backends, and experience team collaboration workflows. Along the way, you'll understand state locking mechanisms, implement proper namespacing strategies, and learn how remote state enables disaster recovery and audit trails. So we have one lesson today, one lab, and then one challenge. For our TLOs, uh, you will master remote state configuration and team collaboration workflows, understand state locking and conflict prevention mechanisms, implement professional Terraform practices for shared infrastructure. ELOs configure S3 plus DynamoDB backends using data sources for shared infrastructure, migrate existing Terraform projects from local to remote state, implement proper key namespacing strategies to prevent team conflicts, experience state locking and understand when conflicts occur, use remote state to enable infrastructure collaboration and disaster recovery, and distinguish between backend infrastructure ownership and consumption. Any questions before we get started with the lesson? Okay, let's go ahead and get started. So the local state problem. Right now, your Terraform state lives in a .tf state file on your laptop. This works fine for personal projects, but imagine these scenarios. For scenario one, the laptop crash. You've spent weeks building complex infrastructure with Terraform. Your laptop dies overnight. All your state files are gone. Terraform has no idea what infrastructure it created or how to manage it, and you're faced with either manually importing hundreds of resources or starting over from scratch, which will be a pain. Scenario two, team collaboration. You and three teammates need to manage the same infrastructure. Sarah makes changes on Monday, Mike makes changes on Tuesday, and you need to make changes on Wednesday. But Mike forgot to share his updated state file when you run Terraform. It doesn't know about Mike's changes and tries to recreate sources that already exist. Scenario three, that accidental conflict. You and a teammate both run Terraform apply at the same time on the same infrastructure. Both think they have the latest state. Both make conflicting changes. Your infrastructure ends up in an inconsistent state that's difficult to recover from. These problems are why no professional team uses local state files in production. So what's the solution? Remote state. Remote state solves these problems by storing your state files in a shared, durable location that all team members can access. Think of it like moving from keeping important documents in your desk drawer to storing them in a secure shared filing system. So the S3 plus DynamoDB backend, AWS provides an ideal uh, remote state solution using two services you learned yesterday. S3 stores the state files, so durable S3 S3 buckets are durable storage with high reliability. It can version, so versioning protects against corrupted state files. The file would then be accessible from anywhere team members work. And there's also encryption, which keeps sensitive infrastructure data secure. DynamoDB, on the other hand, provides state locking. So that prevents multiple people from modifying the same state simultaneously and creates a lock record when someone runs Terraform apply. It releases the lock when the operation completes and ensures only one person can change infrastructure at a time. So how state locking works: Terraform creates a lock entry in DynamoDB with your state file. So when it creates a lock entry into a DynamoDB table, the Terraform writes a new item into a DynamoDB table, and it's usually called something like Terraform locks. That item will contain the state file, which is the partition key or the main identifier, and that state file key is usually the path to the S3 bucket. It also contains a unique lock ID. So Terraform generates this value when it acquires the lock. It contains a timestamp. This just says what date and what time it got created. And then there's metadata about who and what created the lock. So this lock pretty much says this state is being worked on. Nobody else touch it. And again, the item that gets created within the DynamoDB table is the state file key, the unique lock ID, the timestamp, and some metadata. Number two, Terraform downloads the latest state from S3. So once the lock is acquired, Terraform fetches the current state file from your S3 bucket, ensuring that Terraform is working with the most accurate information before planning or applying changes. Number three, Terraform makes your infrastructure changes. So Terraform compares your configuration in your files that's stored locally to the current state, which would be stored in your S3 bucket. And then it'll also compare it to the real infrastructure that's already set up. This helps it determine what needs to be created, updated, or destroyed, and applies those changes safely, knowing no other processes could interfere. Number four, Terraform uploads the updated state to S3. So after changes are applied, Terraform produces a fresh version of the state file and uploads the updated state file to the S3 bucket. If versioning is enabled within the bucket, it creates a history of the different versions. So you do have to manually toggle that on and make sure that versioning is enabled. Number five, Terraform releases the lock in DynamoDB. So it just pretty much removes the lock entry from the DynamoDB table and says other people can work on it now. So pretty much if someone else tries to run Terraform while you have the lock, they get an error message and must wait until you're finished. I know I kind of went over that fast. Is there any questions? Or you guys need any clarification? Okay, let's get into the backend configuration. So Terraform backends are pretty much the components that tell Terraform where to store your state file and how to perform operations like locking, storing, and retrieving data. Think of it as Terraform's state storage and state coordination system. So that's what this block is doing right here. The backend will define where the state file lives, how it is accessed, whether locking is supported, and whether remote operations are supported. You don't need to know that aspect of it right now, but that just means that Terraform does not run on your local machine, but on a remote server managed by the backend instead. This example here is one of the most common and recommended setups for team use in AWS. Here we see that Terraform stores the state file in S3 bucket, and this is the name of it. This is the key, like I was mentioning within the item that gets created into the DynamoDB table. It has the partition key, which is usually the path within that bucket that leads to your state file. Then we have the region. We have the DynamoDB table. Like I said, it's usually called Terraform locks. And then we specified that we want encryption. Any questions? So again, the parameters contained here has the bucket. So it's the S3 bucket name, has the key path to your specific state file, your region, the region where your backend resources live, the DynamoDB table, the table name for the state locking, and then just specifying encryption. The critical importance of keys. The key parameter is like your address in the shared filing system. Each project must have a unique key to avoid conflicts. So some good key patterns are specified right here. Bad key patterns are specified right here. Notice how in the good key patterns you have your name. Usually you would have maybe your team name specified right here, which is actually shown on the second key. So team front end, you might have team back end. And then after that directory, you'll have the actual component or the project that you guys are working on. So for here, on the second one, it says production. You might have one that says development. And then within there, you actually have your state file that holds all your infrastructure information. So with naming things, you don't want to be too generic. It will conflict. And then same thing as this, like multiple people might use project, but if you're all using project, something's wrong. Like you really gotta try and specify what specific project it is so that anybody can just go through and quickly see it and find what they need to find. So name spacing strategy, use your name or team name, then project name, then that's where your state file will live. This ensures no conflict even in large organizations. Local versus remote state. So when you switch to a remote state, what stays the same? The .terraform folder is still created locally. So the .terraform file is pretty much a directory that contains all the metadata and cache Terraform and cache that Terraform needs to run. It is Terraform's local workspace for plugins, modules, and backend info, so it'll always be there. Terraform commands work exactly the same, so even if your state file is remote, you'll still be using the same commands you've been running: Terraform init, Terraform plan, Terraform apply. Your configuration files remain local, so your main.tf, outputs.tf, all your Terraform files. And then this pretty much the same thing as what I said earlier, plan and apply process remains unchanged. But what does change is that your Terraform state file gets stored in an S3 bucket instead of locally on your machine. The state automatically is shared with team members, so anybody from your team can access it. State locking prevents conflicts. State files are automatically backed up and versioned. What's the storage space impact of having it remotely? Local.terraform folders still exist. So provider plugins, cache schemas, but the state files, which can be huge in comparison to uh, this directory, are stored remotely. Significant space savings on local machines, especially for large infrastructure. Any questions on the difference between local versus remote? So for shared backend architecture in your class, this is an example. Instructors manage a shared backend that all students use. Instructor manage resources. The instructors would manage the S3 bucket for storing all student state files, DynamoDB table for coordinating state locks, and IAM permissions for student access. The students would be responsible for using data sources to reference shared backend, configure unique keys to avoid conflicts, migrate existing projects to remote state, and following team collaboration best practices. This will mirror real-world scenarios where platform teams provide shared infrastructure that development teams consume. So migration strategy, moving from local to remote state requires careful planning. Step one, backend exists. Verify the S3 bucket and DynamoDB table are available using data sources. Step two, configure backend. You add your backend configuration to your existing Terraform project. You usually would put that backend in your providers block. Step three, initialize migration. Run Terraform init to migrate state from local file to remote storage. Step four, verify migration. Confirm state was copied correctly and local state file is removed. Step five, test team workflow. Verify other team members can access and modify the same infrastructure. Team collaboration benefits. Remote state enables professional development workflows like version control, shared visibility, disaster recovery, automated pipelines, and access control. So for version control integration, state files in S3 are automatically versioned, providing audit trails of infrastructure changes. Shared visibility, all team members can see current infrastructure state without manually sharing files. Disaster recovery, infrastructure state survives laptop crashes, employee departures, and hardware failures. Automated pipeline CI/CD systems can manage infrastructure using the same shared state that developers use. And access control, IAM policies control who can read or modify infrastructure state, enabling proper security governance. Why this matters for your career. Remote state management is a fundamental DevOps skill that demonstrates you understand team collaboration, operational maturity, risk management, and scalability. So for team collaboration, you can work effectively on infrastructure teams where multiple engineers may manage shared resources. Operational maturity, you understand the difference between personal projects and production-ready infrastructure management. Risk management, you implement practices that protect against data loss and infrastructure conflicts. Scalability, you can design infrastructure workflows that work for teams of 5 or 500 engineers. Every company using infrastructure as code implements remote state management. Learning this positions you for senior roles where you'll design and implement infrastructure standards for your entire engineering organizations. For today's lab, we'll be configuring remote state for your existing projects and experience firsthand how it transforms individual Terraform usage into collaborative infrastructure management. Any questions? I know I kind of went through that fast because there's going to be a lot of troubleshooting later on, so just trying to get through that.
Long story short, we're moving our TF state file to the cloud because DynamoDB will allow only one user to edit it at once, and S3 allows us to store it.
Yep,
Is that correct?
exactly. Yep, exactly. So S3 stores the state file, DynamoDB creates that lock. Yep. Any other questions, comments? Yeah, that's pretty much the key thing you gotta get out of this is S3 holds that state file. DynamoDB will just create that lock so that only one person can be working on that state file or infrastructure one at a time. Let's go to the lab. So for today's lab, we're going to be migrating to a shared backend. So let me just move this window real quick and we can get started. Actually, I think I have to, let me set up my CLI real quick. Uh, let's export. And right now, I'm just configuring my region. Good. So for getting started with today's lab, we're just going to be creating a directory. I'm just going to name it week 8, day 2. Going to cd into that directory. Going to open it up in VS Code. Open my terminal. And then create a main.tf file. We'll go ahead and open it and we can get started. So we're not going to run Terraform init yet. We're just going to set everything up first. So first thing we want to do is throw in our providers. So we have our Terraform code block. It just, again, specifies what version we want it to run, as well as the version of the AWS plugin. So I'm switching this to 4.16 because I know that works on my system. Just change it to whatever's been working for you. And then we have our provider block right here that specifies the region we'll be working in, as well as the profile. We also threw in some data blocks. So there are some S3 buckets and DynamoDB tables already created. We have an S3 bucket called class Terraform state bucket and class Terraform locks. We can go ahead and just double check that to make sure real quick. So we do have the class Terraform state bucket. And then let's double check DynamoDB. 'Cause, and we have our class Terraform blocks table. So we're good to go on that. And these two data blocks will just be able to get that information from those two uh, items or objects, resources, whatever you want to say with it. Um, Next, we'll want to actually add the backend configuration to the Terraform block. So right after this, our required providers section is where we want that backend block to be stored. So again, we'll go quickly go through it. So we're specifying that we want the backend to be an S3 type, and we're storing it in an S3 bucket named class Terraform state bucket. We want our key to be the path of where our state file will be stored, and we'll be wanting it to be specific to where we actually want to store it at. So I'm going to change this to my name, and it's just going to create a folder within that bucket called Eric, and inside that directory named Eric, it'll have the remote state test, and then within it, our actual state file. Next parameter we have is our region. And then we have our DynamoDB table. We're specifying what the name of the table is, which is class Terraform blocks, and we want encryption. So for you guys, if you're following along, just change this to your name.
But we should be using our own profile though, right?
Yeah, yep. So the things you would want to change is the name of the root directory within the bucket, your profile within the providers block, and that's it for right now. Just go ahead and save, make sure it's applied. And then we're going to add some test resources to main.tf. So we'll just add this at the bottom of the file. So we're creating a simple S3 test resource for remote state so that we know something's getting created and that we can actually double check everything. So we specified that we want to create a S3 bucket named test bucket. I'm just gonna go ahead and throw in my name before that too, so I can find it easily later on. Just go ahead and add your name. This is just for you actually don't have to change the name for the actual uh, code block, but down here, it's just it's just best practice, I guess. Just for to always just add your something that helps you identify uh what the item is that you created. But this one right here is just for this specific code block, which you guys are going to see. So, but this this code is practically saying that it's creating a random string of length of 8 characters, all lowercase, and is being called within this S3 code block, and it's getting attached to the end of this bucket name. So when this S3 bucket gets created, it's going to be named remote state test and whatever this random string was that was generated.
Eric,
Yeah,
um, Kevin is asking if you can increase the size of your screen.
yeah.
Or even share that code or a template. Just want to make sure I got every area.
Yeah. should be in the repo. I'm putting the repo URL in the chat.
Okay, great.
So again, it's just creating a random string of 8 characters, all lowercase, and it's getting added to this the name of this S3 bucket. And then for the output, it's just gonna output you the test bucket name. You can move on to step 4. Are there any questions on this code block right here or anything we've done so far?
Think it makes sense. Thank you.
So for step 4, since we've added the backend block within the Terraform block, we can actually now run Terraform init so that it can initialize everything and specify that we want the state file to be stored in that S3 bucket instead of locally. Usually if you don't have this and you run Terraform init, it will be created over here. The only thing that got created was that .terraform directory. And also this file right here, .terraform block.hcl. This file right here is it's Terraform's dependency lock file that locks provider versions, locks provider hashes, and pretty much ensures reproducible and secure runs. It just guarantees Terraform behaves the same for everyone, everywhere, and every time. So when we ran Terraform init in the terminal, we can see some successful messages that got returned. It said that it successfully configured the backend S3. It will use that backend unless the backend configuration changes, and along with other information. So what happens during init, Terraform downloads the provider plugins to the .terraform folder. Terraform configures the remote backend connection. No local state file is created, and the state will be stored remotely from the start. So let's go ahead and hold on 1 second. Let me. So step 5, we'll now go ahead and run Terraform plan. See what it produces. So it's going to be creating 2 resources. It will be creating the S3 bucket, and it's creating that random string resource. And after we hit apply, it'll give us the test bucket name. So let's go ahead and press or run the Terraform apply command.
Eric,
Yeah.
I have a question.
Mhm.
Can you scroll up on your terminal? No. On your terminal, on your
Yeah.
CLI. Wait, go down, go down. It was wait, keep going down. Where is it? Keep going down. Oh, wait, go up. There was something that I saw that I wanted to ask you about. Go up, keep going up. Keep going. Oh, where is it? You didn't, that one right there. You didn't use the out option to save this plan, so Terraform can't guarantee to take exactly these actions if you run terrapply now.
So
Is
So whenever you run Terraform plan, it pretty much like what it says, it plans out everything for you and creates like a blueprint. So when you throw in this option, I guess it kind of saves that blueprint so that when you run Terraform plan or Terraform apply, it will take that blueprint and apply it.
Okay.
So since we didn't add that, it created the blueprint just for a quick glance, uh, for us to have a quick glance on what's gonna be created. But like the message is saying, anything can happen after you run Terraform apply because you didn't save that blueprint. Does that make sense?
Yes. Thank you.
It, uh, everybody else, does that make sense too? So if you add that out option, it just pretty much saves that blueprint and it'll create everything that was stored over there and what it says it was going to create. But when you run Terraform apply, it, I guess it starts new and just runs Terraform plan in the background again and then applies it. So after we ran Terraform apply, we did get output the test bucket name. So let's just copy that and go to our console just to verify. And it did get created. So we're good to go on that. We can move on to step 6. And this is just double checking that no state file got saved locally. There's no matches, that's good. We're checking the remote state storage as well. We'll have to change our name to get the exact file path within the S3 bucket. And the S3 bucket I'm referring to is not the resource we just created. It's the one that stores the state file, which is seen within the backend code block called class Terraform state bucket. So we'll press enter, and this command is pretty much saying from AWS S3, list out all the items within this path. And this is what we got returned. We can double check it on the console itself as well. So let's go to class Terraform state bucket. And then we have our folder here. And we have our state file. So everything got created successfully. And then next, after we check the S3 bucket, we're going to be checking the DynamoDB table. So we're just scanning for whatever's inside the this table itself. So we have a few items, a few objects. Let's go ahead and double check it. And to do that, after you click on the table itself, you just click this orange button so that you can explore the table items. And we have different tables added. So we have mine added over here, so we're good to go. Any questions on that part? So you should not see any local state files. You should see your state file in your S3 at that specified key path. And then you should see your item in that lock table in DynamoDB. So for step 7, we're going to be switching on migrating one of the projects that you guys have already done. It's talking about the EC2 project from day one. So for myself, I'm going to go into week 7, day one, our very first day of Terraform, and use that. And I say to use that because it's has the most simple code, and uh, you'll be able to grasp the concept better. So we'll just open this up as well in VS Code. So right now we only have our provider block, Terraform block, EC2 instance, and our security groups plus outputs. And currently we have our state file locally. So first thing we want to do is to back up our state file. So we're just going to run this command right here, saying copy the Terraform state file to backup Terraform state file. Press enter. I already had it over there, so it's not going to create a new one. Next thing we want to do is edit the Terraform code block to include the backend. So after that required providers section is where we'll be storing the backend block. Let's go ahead and save that. Just make sure everything is correct. So we have our backend S3 type. We have our bucket name, class Terraform, state bucket. We want to specify the same key path that we specified earlier for the root directory. So under your name, or it can be team name. And then after that is where we'll have the component or project name. So for here, I'm just going to change it to EC2 week 7, day 1. And then that's where our state file will get stored for this specific project. We have our region, US East 1. And then our DynamoDB table, class Terraform blocks, and we want encryption. So the only thing that's different from our backend block that we from earlier is that we changed this component or project name. So now that we have our backend code block within the Terraform block, we're gonna want to run Terraform init. We're gonna throw in a tag called reconfigure. And this just says ignore any existing backend configuration and reinitialize everything from scratch. So it's just gonna reset everything. So we'll go ahead and run that. This forces recognition of the new backend and checks if the state file moved to the we'll check if the state file got moved to the S3 bucket. So it says successfully configured the backend S3. So let's go ahead and check. So it did not get added because right now the state file is it's empty, so it doesn't think there's anything there's like no infrastructure that's already set up So you'll see after we run Terraform apply, and then we'll try to do init again, it will pop up after that. So we'll try that. Let's just give it a moment to create. So 2 resources got added, and just for sanity check, let's double check. It did get added because now there is something within the state file. Let's go in the directory real quick. Yep, it's there, so we're good. Any questions on that part? Why it didn't show up and why it showed up after we hit Terraform apply? Okay, let's move on to step. Just go ahead and double check. So we do have our Terraform, our local Terraform state file still in our directory. We can go ahead and delete it since our state file is stored remotely now. And then I'll just keep the backup just in case. So if only thing that will pop up is our backup. And then let's do a Terraform show. And this just shows you pretty much the same thing that gets shown whenever you run Terraform plan. It shows you all the resources that got created and is up on AWS. So we have our EC2 instance. We have our security groups and VPC. Let's try running a Terraform destroy right now. Just because we created or deleted the local state file. Let's see if it will work, and it should. And then we'll go ahead and run Terraform show again afterwards, just to see if anything pops up.
While this is running, would you expand your .terraform folder over on the left-hand side in your file explorer?
Yeah.
No, like the right next to the .terraform. Click, yeah,
Terraform. Okay, okay. Yep.
my bad. Okay.
Yeah, so
So
it's just
that
a chain of different directories leading to the specific
well, inside there is a terraform.tf state, but I assume it's not the terraform.tf state that we care about, right? Two down from your mouse.
oh yeah. Let's see.
But it doesn't look like it looks like a state file for maybe like higher level configurations. I
Mhm.
don't know. I thought it was interesting that there is still a terraform.tf state, but it's not the one that we moved remotely.
Yeah, that's interesting. Let me chat GPT that.
Yeah, I was just clicking around and I was like, hey, wait, it's still here. I must have messed up and it was working. So yeah, it almost looks like it's pointing to where the file is. Like, hey, when you're
Oh yeah,
looking for
yep.
terraform.tf state, you need to look in this S3 or something instead
Mhm.
of locally, right? Does that sound about right?
Yeah, because it shows the S3 bucket and DynamoDB table. So yeah, I guess it's probably pointing to exactly where the state file is located. So it's just maybe metadata for it.
Hmm.
Yeah, because usually that Terraform state file would be in the same directory as main.tf. So that's a reasonable answer for that one.
Yeah, that's what I noticed too. It was in the same directory as main.tf, and then it got moved or
Hmm.
something. So I was like, but it's working. So that must
Yeah,
be the normal how it works.
let's do a Terraform show real quick just to see if everything got destroyed. Yeah, because this .terraform file or directory pretty much just contains metadata and cached uh, items or cached data. So when we do a Terraform show, it proves that our remote state file works because now the state file is empty since we deleted that state file that was located in the same directory as main.tf. But good catch on that, Nick. So let's go on to step 9. Okay, so for this one, I'm going to modify my backend configuration uh, to be the same as someone else's. So who wants to just tell me what they named their key? Because we're going to be demonstrating an error that you can't work on the same state file at the same time because of that lock.
Just change it to Nick dash O'Brien for mine.
Okay.
Wait, no, hold on. The key. S3 buckets, class Terraform. So the thing that's inside class Terraform state bucket, correct?
Yeah, yep. What's
Okay, yeah,
inside
the
the
first part, Nick dash O'Brien, that's right. And then in the second part,
mhm.
the second, yeah, right there, put remote dash state dash test.
Sounds good. Okay, and then now I am going to run a Terraform plan with that detailed exit code flag. So this is just going to keep it up and running for a few seconds. And as I'm running that, just go ahead and run Terraform plan. Or actually, we'll do it reverse. You do the Terraform plan detailed exit code, and then I'll do Terraform plan. Let's see
Here,
what
hold on,
error I
hold on.
get.
I just destroyed it, so let me rebuild it back up just to make
Uh,
sure. Okay. So- Okay, it's rebuilt. What do you want me to run?
so run Terraform plan detailed exit code, and don't run it just yet. I'm gonna delete this and then run it shortly after you run it.
Okay, I'm ready. Tell me when.
All right. All right, go ahead.
Done. Running.
Okay. Wait, okay. I gotta run Terraform init again because we modified the that remote backend. So every time you change your backend configuration, you're gonna have to reinitialize it. So let me do that real quick. Okay, just let me know when you run that command again.
Running.
All right. Yep. So this is the error you would get if you're trying to work uh, on a state file at the same time. So you'll get the error acquiring the state lock. It'll give you
So
some
puts a lock on the state file even if you're just doing Terraform plan.
yeah. Anytime you run a Terraform command, it'll put that lock so that it says nothing else can interfere while you're working on it. So nothing it'll mitigate errors from happening.
That's cool. You can see my computer's name and everything.
Yeah. Yeah, so it shows this is the what was it? The key ID that I was talking about earlier for one of the items that actually gets entered into the DynamoDB table, and then it shows the path, which is the partition key, and then yeah, timestamp, version, and who create or yeah, who is working on it at the moment. So it
So
also
that's
shows
just the date though. Like what if how does versioning work though? Like if something that you like Nick does, mm, I'm just trying to think like if they conflict, like if there's something that one of you does that conflicts that
so
maybe that I don't know.
you're talking about the versioning. So whenever
Yeah.
since it creates that state lock, only one person at a time can create it. So any modification they do will immediately and automatically update that state file and create that new version. So that way it's always updated and up to date so that no
Yeah,
one
but if
will
the
be
next
behind.
person does something else
Mm,
and
There's one
changes
source of
everything
truth
back,
now.
yeah.
So instead of having the state locally, the state is being held in the cloud on AWS. So anytime before you do a Terraform action, it's going to reference the state file that's in the cloud. So that is the truth. That's the version, right?
Yeah, I'm
mm,
just picturing, so like say, you make something like you make a database, trying to think of something like or a VPC or something. I guess the next person wouldn't be calling that same thing because it would have a different name. So I guess it would just continue to add on to it, rather than make changes. I was just thinking if there's any kind of instance where there would be a conflict.
I would say no, there's not going to be a conflict because again, only one person can work on it at a time. So whatever changes gets made, uh, is reflected within that state file, from the last person who was working on it. Does that make sense?
Yeah,
Uh,
I'm talking about, I think I'm not articulating my point. It's fine. We can move on.
Kevin has a question.
Hey, Kevin, can you explain further what you meant by that? What if someone messes up?
Sure. So let's say me and Nick. So Nick locks it. He gets done what he does, right?
Hmm.
And I come in, since there's no versioning, and let's say I did something incorrect and we needed to roll back to what Nick did. Do I have to contact Nick and say, hey, go change it? Or do I just have to have the same, like, you know how you can change without versioning? You ever was doing code and you're like, wait a minute, I don't remember exactly how I had it. So
Hmm.
what would happen in that scenario? So we need to roll back to what Nick did. Do I need to contact Nick and say, give me that code? Or is there a mechanism in to do that?
Yeah, your best bet for that would be to contact Nick to either
Okay.
rerun that infrastructure.
Okay.
So you would probably have to, if you applied something and re-updated that state file, just to go ahead and destroy everything after
Yeah.
that, and then contact Nick to have him rerun everything.
Okay.
And you can keep track of Terraform files with Git and GitHub, right? Just
Yeah,
like any
yeah.
other file.
Hmm. Yep.
Oh, okay.
Yep. Or you so you can have Nick run it, or you can get Nick's code and then run it yourself.
Okay, so if we had some kind of shared repo,
Hmm.
right? I can look in his if he did a feature branch or if I did, or I can go back to main. Right, okay. And reset. And I
Yeah.
shouldn't be making changes on main anyway, right? In the same right. Okay. So he okay.
And most likely too, if you're working on in a team, on on Terraform, you have that state file, but you'll also have version control so that everyone's code is always updated as well. So those kind of pair up together so that there's no you can so errors are mitigated as much as possible. Does
I
that
have a
answer your question?
question.
Yeah, go ahead, Mike.
And this is just when I was listening to what they were saying, and I'm not sure about on the DevOps side, but for something like this, because it affects the infrastructure,
Mhm.
do they have a dev side versus a prod side? Right? Because this is directly related to the infrastructure itself, which is live and it's a production.
Mhm. Yeah,
Right.
so yeah, usually you'd be making everything probably in like a test environment first, and then you'll have CI/CD set up so that once you run everything, it will first test it out on the test environment, and then eventually, after all the checks are completed, it will migrate everything to production. Was
Okay.
that what you're asking?
Yes.
Okay.
Yeah. And that's just because I had heard them mention GitHub, and of course that's for files and versioning, but
Mhm.
the Terraform itself, that's infrastructure production, right? That's
Mhm.
something. So that's what made me ask that
Yeah.
when I was listening. So, yeah.
Yeah, so
Thank you.
everything, yeah, in a work environment, everything's probably going to be working in a test environment, development environment first, and then run through all those checks, and then it will get pushed up to production. So everything is going to run through checks first. Any other questions, Kathleen? Do you want to retry that question you were asking? Because it seems like I didn't answer it.
No, I think it just has to do with, what exactly we're sharing. I think some of what Kevin was asking was similar. So I'll just maybe do some research on my end and try and find it.
Okay. All right. So we just saw that whenever you're trying to run, if someone else is working on the Terraform state file, then and you try to work on it, you'll get a error acquiring that state lock. So it'll give you pretty much who's working on it.
So since my Terraform plan dash detailed exit code ran and is done, now can you access it
Yeah,
without it being locked?
let's try. I'll run Terraform plan again. You should be able, or I should be able to, because now the state lock is not being accessed. There's no key in it, so now I can use my key, if that makes sense. So, yep, everything ran smoothly since I was the only one working on it. Okay, any questions before we move on to step 10? Access from multiple locations. Okay, so for step 10, we're just going to create a new directory. So it's just we're just going to demonstrate that you can work with a state file from anywhere. So create a so many VS Code windows open. All right. Okay, so we're going to be creating a main.tf file that has that backend configuration. Just quickly go through it. And I hate how this is set up, so let me just change it up real quick. All right, let me actually reconfigure my reconfigure the backend to mine. Got what I named it. C2. Okay, now we're just gonna reinitialize this. Okay, that was gonna pop up.
Then you got it. Oh, yeah, you got it.
Yeah, I keep on doing that. Like I mentioned it before, I keep on doing Terraform. All right. And yeah, whenever you throw in that backend block, just add that reconfigure flag to the end of that Terraform init just to be safe. So you know everything's starting from scratch. Let's do Terraform show.
Terraform. I do that all the time too. I don't know why.
It's because I use from more than form, you know. So it's not going to show anything because there's no infrastructure that's populated. So that's why it's taking forever. Let's just cancel this operation right now. Let's go ahead and create our resources again from the week 7, day 1. God. Wait, hold on. Did I reinitialize this? I don't know if I did, so just going to go ahead and do it. Now we can do Terraform apply just to set everything up. when you have really big infrastructure, sometimes it'll take like 5, 10 minutes to set everything up. So sometimes Terraform takes a while. So everything got created. Let's do a Terraform show. And now it is actually populating with the infrastructure that we just created. So this proves that you can access that Terraform state file from anywhere. Go ahead and move on to step 11. Right now, we're just going to check our different versions within our state file. So specify the path, EC2. And we have our different versions stored here. Let's try. We have how many versions? 1, 2, 3, 4, 5, 6, 7. We have a bunch of different versions. Does that part make sense? Just checking the different versions. One thing I also did want to tell you guys was a command to hold on. So if Terraform crashes or you're disconnected mid-apply, you can manually remove the lock by running this specific command. Terraform force unlock and then the lock ID. So earlier when I tried to run Terraform plan, but Nick was already on the lock, it stated it gave me the error that I couldn't acquire that lock because Nick was already using it. So it gave me the lock ID. Is it still up? Okay, we don't have it up here, but it gave us the lock ID, so you would just put that in over here. Now you'll probably have to look up the lock ID manually in the DynamoDB table, but otherwise it should be specified in the error log. And you have to be really careful with running this command and make sure nothing else is running. Um, let's check the state file encryption. So we know that it is encrypted. Any questions so far in the lab? So understanding local versus let me switch back.
I'm running a little slow, a little behind conceptually. How does changes you make to your main.tf and then run through the lock get over to Nick's main.tf? Right, so he now has a new state, but his main.tf doesn't represent the new state. Did we cover that? And I'm sorry if we did.
No, so the state file remotely is always gonna reflect what is uh, I guess what is built on the on AWS so that whatever is on your main.tf files locally may be different from one another. So one way to fix that is to use version control like GitHub so that you guys have the same code because that state
Okay.
file is only going to reference Nick's code. So it's not you might have a completely different code or maybe even a different project or have things set up differently.
We
That's
did
not
remember
reflected
that.
in
All
the
right.
state file.
Yeah, appreciate you. Thanks.
Any other questions? Okay. Does that answer your question, Troy?
Yep.
All right. So understanding local versus remote folder structure. Uh, before remote state, you'll have that state file and then the backup. After remote state, everything is going to be stored within the S3 bucket so that different team members are able to access and utilize it. Key insights, that Terraform folder still exists, both locally or yeah, just locally. And then the state file is stored remotely. Multiple developers share the same remote state, but have their own .terraform folders. Step 13, configure all your projects. You guys can configure all the projects you've been working on just by adding that back end code block and then reinitializing it. View, verify your remote state setup enables. So this command right here is just going to list everything that's within that class S3 bucket. So it's saying list out everything from the S3 bucket, class Terraform, state bucket. So we have four different directories, Cam, Camaro, Eric, and then Nick, and then it just pretty much lists out every single state file that is stored within the S3 bucket and gives the path to it. Does that make sense? Let's go back. And this one is just going to show the items in the count of the items in the DynamoDB table. So what you should see, we saw multiple students' state files with different key prefixes. Each student can work independently. Shared backend infrastructure is managed by instructors. So for cleanup, I would just run Terraform destroy, make sure everything is not up. So I'm just gonna go through all these different VS Code, just run that command. I don't think we created anything here, but let's go ahead and do it anyways. Same thing with this one. Okay, see, we got the acquiring the state lock error because this one right here, this project and this project share the same state file. So I was not able to run any Terraform commands over here. This one, on the other hand, is in a different state file, so we were able to run that command. Why is this taking forever? Sweet. Okay. So what you've accomplished, you've successfully configured remote state backends using shared class infrastructure, migrated existing projects from local to remote state management, experienced state locking and team collaboration workflows, understood security and versioning benefits of remote state, implemented proper namespacing strategies for team environments. You now understand how professional teams manage Terraform state at scale, enabling safe collaboration on shared infrastructure. This foundation prepares you for enterprise DevOps workflows where multiple teams coordinate infrastructure changes across complex cloud environments. Any questions on today's lessons? All right, I'm gonna stop the recording.